The atomic mass is the mass of an atom and normally coincides with the mass of the protons plus that of the neutrons. The reason why electrons are not factored in is because their mass is much smaller than that of protons and neutrons. The value of the atomic mass for each element can be found in the periodic table, normally below the symbol, as is shown by the picture. And you see the number that is indicated by the blue arrow is the atomic mass of chlorine. Now, the number of protons is easily found out by the in the periodic table as well, and for chlorine is 17. Now, we do know that an element always has the same number of protons, and that is its identity, but it can have different number of neutrons. Just as a reminder that elements that have the same number of protons but different number of neutrons are called isotopes. The mass that we see there does not reflect any of the case scenarios that we see here for chlorine. So you have a chlorine with the mass 35 and a chlorine with the mass 37 because they can have either 18 or 20 neutrons, but you don't see either number. You don't see an average between the two. So what is the number that is found in the periodic table? As it turns out, it is an average, but it is a weighted average, and it depends on the natural abundance of each isotope. So if you see, for example, carbon, there are two isotopes, one with atomic mass or isotopic mass 12, and the other one with isotopic mass of 13.003355. The natural abundance of these two is different. And so when we see the atomic mass for the carbon as being 12.01, is taken into account that there is more carbon 12 than there is carbon 13. The units for the atomic mass are AMUs, so atomic mass units, which are defined as 1/12 of the mass of a carbon-12 atom. Now, how do we calculate the atomic mass? We said it's an average, and in general, we're used to do averages as the example you see. So you see a student has 80% in one exam, 72% in another exam. What does the student have as a grade? And normally we just sum up the grades, divide by 2. But what happens if the teacher decides that the two exams are going to be weighted differently? Then in this case, and I'm going to pass on to my pad, we have that the teacher decides that exam 1 is 67% and exam 2 is 33%. So in this case, in order to calculate the grade, so suppose the grade for this exam is 80 and for this exam is 76, what you need to do is take your percentages, transform them into numbers, and you do that by dividing them by 100. So 67 divided 100, and you multiply it by the actual grade, 80, and then you can sum up 33 divided 100 times 76. And this is going to give you the weighted average of your two exams. And you see that in this case, you're going to get a number that is higher than the average of the two exams divided by 2, because your exam where you have a higher grade is weighted more. And your exam average will be 78.68. So in general, we can apply the same concept to calculating the average atomic mass. So you see that you have a formula there where it tells you that the atomic mass is going to be the sum of fraction of isotope, where the fraction is going to be that percentage divided 100 that we were looking at, multiplied by the mass of the isotope. And we have to do this for each and every isotope. So we're going to now look at some examples on the and how to calculate the average atomic mass of elements. Silver has two isotopes. The first isotope is silver 107, and the second isotope is silver 109. And the masses of these isotopes are respectively the atomic masses 106.90509 AMU and 108.90470 AMU. The abundance are respectively 51.86% and 48.14%. Now, what I want to do is, while I'm pulling out my data, I want to write these abundances directly divided by 100, because I want to be able, and I'll show you how I'm going to use this kind of table setup to calculate the average atomic mass. I want to be able to make operations, and we said I need to divide those by 100 to use them as numbers. So I'm going to write them directly 0.5186 and 0.4814. Now, once I have my information organized in this manner, it's fairly simple to get the average atomic mass. All I have to do is multiply these two quantities by each other and write the result here. So this will give me 55.44, and then I multiply these two, they're going to give me 52.43. And then I simply sum up these two numbers to get the average atomic mass, which is 107.86 AMU. Now, this method is very convenient, and I can use it both to calculate the average atomic mass or, for example, to calculate either a natural abundance if I have all the other data, or one of the masses for one of the isotopes, again, if I have all the other data. So say, for example, you have chlorine. Chlorine has, we said, two isotopes. One is 35 and one is chlorine 37. And suppose you have the mass of one of the isotopes, and it is 34.97. And this has an abundance of 75.77%. So in this case, I'm going to write 0.7577, having divided that by 100. Suppose that I know that I have another isotope, 37. Now, the abundance of the other isotope, I don't have to have that given to me, because it will be 100 minus 75.77. So I can write directly this as 0.2423. So whether it's given to me or not, I can still find out that number. Now, imagine that in a case like this, I'm told that the actual average atomic mass of chlorine is 35.45 AMU, and I'm asked to find this mass. Well, in this case, what I can do is multiply these two numbers. So 26.497 is what I get. Then I can get this as the difference between the average atomic mass and this quantity. Because remember that the average atomic mass is the sum of this plus this. So the difference is going to give me this number, which is 8.953. Once I have this number, because this was obtained up here by multiplying these two quantities, so if I divide, then I can get these quantities, so 36.95. So you see I'm doing the same kind of layout, I'm just working it backwards in this case.